Hello, good afternoon. Welcome to the third installment in the hydrological modeling stories. That's an IUPWARE webinar series this month. Um, our focus is on success stories from alumni of the Water Resources Engineering program. We're especially looking at, well, hydrological modeling success stories, but how they've used that in their careers. These webinars are free and open, and we really aim to capture as wide an audience as possible, specifically current and prospective students, researchers, professionals, as well as alumni along the way. Um, so we've already had a talk 2 weeks ago from Douglas Ignole about the Watershed Investment Program. That's a way to address water scarcity with nature-based solutions, and a talk from John O'Cady about dealing with data scarcity in Africa and the potential of the Internet of Things to satisfy that need. I'm going to introduce at the end of the little presentation our next speaker. That's Imeshi Werasinga. I'll speak a little bit more about her and the subject of her talk. But first, I'm going to introduce a couple of slides about the Water Resources Engineering program from which these alumni have come. Um, the IUPWARE program is the focus of which is really numerical simulation tools with the aim of implementing integrated water management solutions. And that's done through hands-on training and excursions. And then our graduates earn a joint degree from KU Leuven and the Free University of Brussels. Um, this is the layout of our curriculum over 2 years. The overall aim is for the first year to establish a common base from which students can then specialize in the second year with a broad selection of electives here that you can see in the bottom half. Um, the thesis carries 28 ECTS weights. So, I mean, it's the most important work that our students will have to complete. But we have other projects along the way, such as the integrated project, which bring together the learning of the previous years towards the end of the program and allow students to experience um, an environment which will be similar to most of their professional projects that they will undertake. And these integrated projects really rely on the network of alumni that we have built up um, uh, globally. As you can see from the destinations where we've held our previous integrated projects. Um, there's been a few changes recently in our program. The addition of some third semester exchange options, specifically a specialization in wastewater treatment. That's with one of our alumni. Well, I introduced him at the start. John O'Cady has been instrumental in setting up this specialization at the University of Cape Town. And then we also have Erasmus exchanges with the Czech University of Life Sciences and Warsaw University of Life Sciences. Another new option is, well, aim to gear our graduates towards their professional life, and that's an opportunity to take internships as elective courses for 6 ECTS. So we really have built quite an international community, with now this year hitting 1,150 graduates from over 100 countries. And with this international community of graduates, we aim to remain involved with them through these webinars and also trainings and events, as we've had in the years and listed on the right here. So if you want more information about the program, I really encourage you to go and check out the website or to send an email to this address. But now I'll introduce our speaker today. It's Imeshi Werasinga, and she's a graduate from 2014 of IUPWARE. And 5 years after that, she established and co-founded the company WIO. The subject of our talk today is environmental analytics for all using data from space. And you can really see, I mean, how this is the what drives her for pushing her company forward as she works towards a greener planet. And we'll let her take the floor now and to give us an insight into her journey, which is a blend of academia, entrepreneurship, and a deep commitment to sustainability. Thank you, Imeshi, for joining us.
Thanks a lot, Brian, for a lovely introduction. Hello, everyone. So my name's Imeshi, and along with Charlotte Virion, we co-founded WEO, and what we're all about is providing environmental analytics for all using data from space. But before I go on to talk more about WEO and what we do, I thought I would give you a little bit of an idea of how we got here. So I was born in Sri Lanka. I grew up in Australia, and about 11 years ago, I moved to Belgium. And so I really saw all the different issues that you can have with water throughout my lifetime. So in Sri Lanka, for example, there's a lot of issues with water quality. We have quite an abundance of water, but it's not equally distributed. I don't think I need to go into too much description about all the issues in Australia with water. There is drought, floods, and wildfires, for example, all in one season in different parts of the country. And I came here, and I'm a very happy alumnus of the IUPWARE program, and learned all about water resource engineering through that. And that actually in VUB is where I met Charlotte Virion while we were doing our research using remote sensing to look at different aspects. Charlotte on looking at quantifying urban fluxes in using remote sensing, and myself looking at climate impacts on agricultural productivity in Africa using remote sensing as well. And we actually instantly connected on many, many different levels, but also in our like and passion for environmental sustainability. And what we really wanted to do, especially after a few years of meeting each other, we both became parents. So she's a mother of two, and I am also a mother of two. And it really became very important for us to, even more important, I should say, to really create a more sustainable future. And through our research, through our education, we got a lot of tools to be able to do this, and we decided that it would be a very interesting way to start WEO, to try and facilitate innovation and technology, and transfer this to the community and the citizens at large. And so this is a little bit of a history. I've put both of our degrees there, but happy to talk a little bit more about us later. But I thought now we can go into what WEO is all about. So as you're well aware, if you're listening to this as well, I think you know that it's imperative that we look at climate risks and climate impacts in our cities and to our companies, and to try and understand, mitigate and adapt and find solutions for mitigating and adapting these. And so one of the main ways that we see is to make our cities greener and to make our companies greener and to understand how we can do this. And one of the best ways to do this is really to monitor our environment. Now, one of the main problems here is that there's a lot of data. There is so much data out there, but it's not necessarily always usable or in a form that is easily digestible for cities or for different companies or end users to be able to use directly in their daily tasks. And one of the other issues is that even though there's a lot of data out there, it's sometimes inaccessible. So, for example, commercial imagery, satellite imagery, can be very expensive, and so it's not necessarily easy to use this at scale or at regular frequencies where this environmental information is actually critical. So what WEO does, and what we did, is we created technology that can enhance the resolution of satellite imagery by combining combining different sensors and combining different sources. And so what it does is it really extracts different insights that were previously not necessarily available in its native form. And the idea is that we can apply this tech not only on commercial imagery, but also openly available satellite data, for example, like the Copernicus, so Sentinel data from the European Space Agency, or Landsat data that is available from NASA. And so the end products that we deliver are very accessible, so they're affordable, they're also regular, and they're also consistent, so they're comparable over time. So to give you a little bit of an example of what this might look like, so you see on the left here is the native resolution of thermal imagery from Sentinel, so Sentinel-3 imagery. It's brightness temperature, and we've extracted this to be land surface temperature, basically. But what you see here is the native resolution. So, you know, the gray and white boxes don't really look like a lot, and there's not a lot of information that you can extract, especially if you want to look at neighborhood or street level. And then you see in the middle there what we can do globally with without any combination of extra or higher resolution data. And so we can get to a 10-meter resolution anywhere in the world. And then on the right, what you see is if we have additional information, which is often available from national geoportals, they have done either orthophoto or aerial campaigns or LiDAR campaigns. So once we combine this further with our technology, we can enhance our models and get even greater or even more enhanced resolution. So this one you see here is at 1 meter, but we've also worked with a client where we went to 10 centimeter resolution. So I talked about the tech and what that does, but then we go one step further. So we enhance the imagery, but then we extract different products or different thematic areas that we look into, and we extract different products that our end users and our clients can use. So there are 4 different product lines, and what we do here is we look at urban resilience, we look at tree health and growth, we look at risks for physical assets such as railway lines or for utilities, and we also look at wildfire risks. So the third product line, I just talked about risk, but it's vegetation risk, whereas the 4th one is specifically wildfire risk. So I'll go into a little bit more detail of each of these product lines. But first, what I want to say is the common theme for all of these products is that we take satellite imagery, we do the enhancement, and then we extract all these different thematics and products in the form of maps and also indicators, as well as consultancy, using it's an automated data processing pipeline. So that's what we've built. So this slide looks a little bit different, but what I want to show here is really our urban resilience product line. And for this, what we look at is a city can give us an area. So you see here on the bottom left, a commune X can give us an area they want to look at, and we can then do different analyses for them. So we can look at existing green roofs, where they're located, and the potential for new green roofs. And this helps them, for example, see if their incentive programs are working. We can also look at the location and the health of trees, and this helps them avoid tree losses and their associated costs and benefits, for example. And then we can also overlay this with like land surface temperature maps, so to look at urban heat island effects, to understand which neighborhoods are at risk of urban heat islands, and to help identify these, to avoid, for example, building more construction in these areas, or to help plan and prioritize for vulnerable populations that might be at risk of these extreme heat issues. And then there's also the sealed surfaces that we can look at, and we've actually worked with Brussels here to map the sealed surfaces in Brussels, to identify, to help identify and support their looking at which areas might be prone to flood risk, or again to heating up, for example. And I've talked about all of these, so I'm not going to go into this. This is just another look at the green roof detection. So just zoomed in that. And here again, this is something that's really interesting. You can really see, if you look at the numbers here, we did a analysis for a city in Luxembourg, where they wanted a comparison at street level between one street that was tree lined and one street that was not tree lined, and there was a 6-degree difference in temperature at the same time on the same day. And so they used this to take this to the budgetary committee, and they got budget to plant more trees. So this is an example of how they use our data to really make a difference. And another aspect that we look at, and I wanted to focus a little bit more on, is we look at vegetation and trees in particular. We look at where they're located and how they're growing, but we're also looking at the quality of vegetation and green spaces. So here we identify trees that are undergoing water stress. This is really important to understand planning and irrigation schemes. So this is something that we're doing over time for municipalities, and they're using this to change the way that they implement their city watering. Another thing that we're looking at is to identify the damage, so the health, not looking at seasonal water stress, but to look at the actual damage of a tree by looking at the defoliation and the discoloration aspects. And this is really, really important also in understanding how vegetation can pose a threat to assets, which I'll go into in a second. But it's also actually really interesting and important to identify trees that are in poor health early enough in order to avoid tree losses. Trees are extremely expensive, and so when we lose an old tree, for example, it's very difficult to replant a tree that is the same age and that might have the same benefits. So it's really better to avoid to lose this in the first place, and that's something that we do with cities to identify trees or vegetation in general that is in poor health early enough. Now, the next one we want to talk about is really vegetation that poses a risk to assets. So again, we want to protect assets here, but we also want to protect the vegetation. So again, when we identify vegetation early enough, that is either posing a risk because it's growing into the asset. So here you're seeing railway lines. So you want to avoid trees interfering with the train tracks. And you also want to identify trees that are, again, in poor health prior early enough so that we can save the tree rather than cutting down a tree, and keeping the benefits that this vegetation gives us. So we work with the National Railways of Luxembourg as a pilot client to help them optimize their vegetation maintenance. So instead of visiting every kilometer of the track, what they can do is we pinpoint the areas that they need to prioritize using a traffic light system. And then they can go to that particular area, and whether it's looking after a tree or pruning the tree because it's growing into the tracks, that's what they need to do. So instead of doing this every 3 years, for example, they can really get regular updates every month if they want it. And so this is something that we've optimized for them. So the last thing I will talk about today is something that's very close to home because I am an Australian. And so what we do is we also look at wildfire risk. And really the main way we look at this is using vegetation again, but it's not just the proximity. We look at how close the vegetation is, the structure of that vegetation, and then we also look at the flammability of that vegetation. What you see here is a critical pump station in South Australia, which was unfortunately missed in their maintenance scheme because they've got thousands of distributed assets to maintain over vast distances. And so doing this manually is not optimal. And so they missed this station. And unfortunately, this station was burnt down during a bushfire season. And this station provides 30,000 homes with water. So this is a huge deal. And so the way to help and to better monitor and optimize the maintenance and management of these distributed assets is to use satellite data like ours that can monitor this regularly as well as consistently throughout large distances as well as through frequency of time. And this can also show you the importance because, I mean, as you can understand, Australia is very, very vast. And so if you needed to do aerial campaigns or even by commercial imagery, this is an area that could become extremely expensive. And so using open satellite data is one of the ways that we can make sure that this information is accessible to clients like these. So just to give you a little bit of an idea, these are some of the clients that we're already working with. So most of our clients to date are municipalities and governments, but we're also getting a lot of interest for our information and products by infrastructure managers like National Railway Lines, but also developers, real estate, banks and insurance companies as well. This is something that's really interesting. So we've actually been selected for some great accelerator programs that we've gone through and are going through, and without these actually they've just provided us so much support. We wouldn't be where we are without them. And we've also won several awards such as Copernicus Masters and different startup stories and so forth. That just gives us the motivation and the knowledge that we're on a right track and that this is a gap that needed to be filled. So the most important part, we started in 2020, myself and Charlotte. Well, we registered in 2020. We started earlier than that. And now we're a team of 8. And it's really wonderful. We've got some really top talent and a really diverse mix of genders, of countries, of cultures, as well as of experience. And one of the main aspects is everybody is really sharing the same vision as us, and it really motivates us to work in this team together and drive our mission along. So that's it from me. I think I'm just on time to answer any questions you all have.
Well, thank you very much for that very interesting talk, Yamishi. It's a very, I mean, quite a captivating story and a very interesting path that has been laid out. Like you say, you're really meeting a need in the market, it seems, for these kind of services. The floor is now open for questions if there are any. If not, I'm gonna set one out. Yeah, well, we wait for any other questions. I would have one. So in your data flows, um, do you find much need for ground reference data?
Yes, so the way we do that, to be honest, is when we actually work with a client. So often we're doing pilot studies for clients, and they are our reference. So they've got either expert knowledge or a lot of ground truthing that we can use to ensure that our models are working correctly, and we're getting quite high accuracy. So we work in Luxembourg, so we're getting quite high accuracy in Luxembourg. So it'll be very nice
Yes.
when we've got pilot clients around the world to be able to test this out.
Yeah, yeah, indeed. And I mean, there's such a wealth of remote sensing data that just seems to be increasing day on day. Do you have, we'll say, a kind of a preference? I mean, it's a tough one to say, but products that you prefer to work with and others that you don't look at so favorably. I mean, maybe it's the interface for accessing the data or um, anything like that.
Look, to be honest, our main product that we work with are Sentinel products from the
Mhm.
European Space Agency, and they're quite nicely accessible in the sense that there are great API. Well, there's a great API that we can extract these with
Yeah.
and just integrate into our product pipelines. So it works quite well for us.
Yes.
Yeah, I see we've got another
Yes.
question.
Yes. There's a question from Rediet. Um, what metrics do you use to assess whether a tree is a risk to infrastructure, for example, the railway?
Yeah, so there are different metrics that there are different characteristics that we use to judge whether a tree is at risk. So it's the proximity. So different pilot clients have different characteristics. So there's the proximity, there's also the slope, there's also the type of tree. So you can understand that some trees have shallow roots, some trees have deeper roots. This also makes a difference. Whether it's healthy or not. So whether there's a risk of falling over, and also the slope
Yeah.
of where it's positioned. I might have forgotten a particular
And
characteristic. I
information about the
apologize if I have.
type of tree is something that's accessible spatially.
Yeah, look, the type of tree, and you don't go into specifics. So it's
Yep.
really if you just distinguish between deciduous and coniferous,
Okay.
that
Yeah.
already gives you a good
Yes.
idea because it gives you the shallow and the deep roots, for
Yeah.
example.
Indeed.
We are working on going into more specific tree types, but that's not something that we've gotten to
Yes.
date. We can just identify deciduous versus coniferous.
Yes. So there's a question from Sebastian. What are the minimum characteristics of the satellite imagery used? Um, I'm not sure about what
Um,
minimum, probably resolution and the spectral
yeah,
and
sure.
uh, spatial.
So look, the open satellite imagery, so Sentinel missions, for example, it varies for the different sensors. So if you look at optical imagery, you can get certain bands that are 10-meter resolution, you can get certain bands that are 20, and certain bands that are 60. And for many use cases, that is still, you can imagine, even 10 meters, it's really difficult to spot a tree. So we do need to enhance that to at least a sort of meter resolution to be able to understand where a tree is located and how it's growing and how healthy it is. So I hope I've answered your question. And for example, thermal imagery from Sentinel-3 is at 1 kilometer resolution. When you're looking at street level, that's too coarse. So we need to again enhance that, and we can go to generally 10 meter resolution and sub if there's further data available from the customer that we're working with.
So that, I think that leads in nicely to the second part of the question, which was, what are the current difficulties in working with this technology, with this type of technology?
Yeah, so I mean, spatial resolution is definitely one of them, and that's a difficulty that we're trying to, and we have resolved, or at least certain use cases. And the other one is really the clouds, which is always an issue, especially for thermal as well as optical. So obviously, when we resolve that, that'll be amazing.
Yes. And speaking of clouds, do you use much radar data?
Yes, we do. We're starting to use it in terms of flood monitoring, as well as looking at sort of the meandering of waterways and so forth. That's something that we're looking at using radar data for. But for tree detection or for thermal for heat detection and so forth, we don't use radar at this stage.
Yes. So Annalise says, congratulations on the success. She's wondering if you've done any applications in water quality monitoring.
Yeah, we've done a small pilot in that. And one of the ways is actually to look at the temperature of water. And don't forget, we can only monitor the surface. So it's really not the whole water body that you can monitor, but just the surface. So you can look at, for example, the temperature, which gives you a good indication, but also the chlorophyll content, that also gives you an idea of the water quality.
Annalie again. Just wondering what type of data is necessary for the enhancements you've mentioned.
So what we've created is technology based on deep learning that does this. So you need training data, obviously. So the higher resolution you go, that should be available. For example, if you want to go to 10 centimeters, you need to have that data available from different areas, and that can be again orthophoto. So the Visnia optical bands to help you enhance
And
the different sensors that we use.
would they usually be provided by the clients?
Not
Those,
necessarily if they have
okay.
it, yes, but if they don't, it can be bought.
Yeah.
There's commercial imagery available, and if they do have it, then it's often available in national geo portals, especially in places like Europe. This is not necessarily the case in other parts.
Yes.
Of the world.
And most of your projects have focused around Europe.
At this point in time, many of our projects have been focused in the Benelux region. Now we're expanding to further afield in Europe, but we've also done some projects with development teams in Africa and Niger, as well as in Australia, as well as in different parts of the world. So the idea is the main driver for us was really to make this information accessible and democratize it for anywhere in the world. So really, we would love to do projects that are outside of Europe, in Asia, in Africa, and so forth. It's just a matter of getting projects or getting funding if we can.
Indeed. Yeah, there's, I mean, such a need for this digesting those outputs and making them interpretable and usable, because it's daunting otherwise, and it's all there available, but not so
Exactly.
accessible actually. in other
Yeah,
ways.
exactly. And that's something that we do actually. We provide the maps and the indicators, but for many clients, they don't have the capacity to actually do the analytics themselves. So we actually do the analytics and provide, should plant trees here, for example,
Yeah.
as also a service that we provide.
Yes. Pedro asks, what programming language do you use the most for your analysis?
Yeah, look, we do use Python. And you ask what libraries you suggest. And to be honest, I am the CEO now, even though I've got a good background in technical. I do not do the programming anymore. So I would have to get back to you on those questions, I have to say.
It's, I can imagine your time can't be spent coding too much anymore.
No, I
Yes.
would love to be honest,
Yeah,
but I just don't have the time anymore.
yes. Tamer asks, or sorry, it says, thank you for the interesting presentation and congratulations on what you have achieved.
Thank you so much, and my absolute pleasure.
Okay. I think we still have, yeah, I think that wraps it up nicely. Really, thank you very much, Imeshi, for your time and for your very interesting presentation. Well, it's great to see. I mean, myself, as someone who has struggled with remote sensing data, it's just yeah, it's really great to see this bridge being made to make the data available and to digest it for a wider audience. It's fantastic. Okay,
Thanks,
so thank you
Brian.
everyone for joining, and we'll see you next week for our next speaker. There'll be information following during the coming days about that. Thank you.
Thank you.